guys. Gotta have our intro music, right? Of course. Welcome to another edition of Patio Productions, where we do pre-calculus in my backyard. Super fun. So today's lesson is going to be talking about some very specific sequences that we introduced in our previous lesson. So in our previous lesson, we talked about a sequence, and a sequence is basically just a list of numbers. They're separated by commas, and then they have some sort of a pattern to them. And so what we're going to do today is we're going to talk about two specific kinds. Okay, two specific kinds. One of them is called arithmetic, and one of them is called geometric, and that's what we're going to talk about today. So I'm going to go ahead and get my screen shared here so that we can go ahead and pull up the PowerPoint. And so here we go. Let's get started, guys. Okay. Again, we're talking about arithmetic and geometric sequences. If you need to, you might need like a scientific calculator for just to do some quick calculations for today. So if you want to go fetch that, I will just regale you with a fun story. Just kidding. Get those calculators, guys. Hurry, 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 hurry. I know. Was there any traffic finding that calculator? Just kidding. I'm sure you got it. I'm sure you got it. Okay, so there's going to be some definitions. There's kind of a lot of examples, but not a lot of slides. Reminder, you can totally pause this video anytime you need to. And then you're just writing down the most important things. You don't have to write down everything. Just write down the stuff that you need. And I'll try to like highlight and, box up like the really, really important stuff. Okay, so this is, and guys, I know you're going to be like, Mrs. Fox, there's a lot of notation. I'm fully aware of this. This is how we define it, and then we'll talk about it like in more Englishy terms, okay? So an arithmetic sequence, this is defined recursively. We are going to do the explicit version also, because we talked about explicit and recursive yesterday. So an arithmetic sequence, defined recursively, is a sequence where a sub 1, comma a sub 2, comma a sub 3, if there's a constant d for which, and let's kind of put this in English, right? Like that's always important to think about this in English here, and where whatever term you're on is the previous term plus a certain number for n greater than 1. And so we say it's a sub n is equal to a sub n minus 1 plus d, okay? Defined explicitly, and we are going to talk about what this d value is in just a moment, okay? Defined explicitly, and guys, I'm going to be honest with you, this rule right here, this guy, which I'm going to attempt to box up and not be super ugly, okay? Easier said than done, okay? This guy right here is basically what you're going to memorize because he is the formula for explicitly define an arithmetic sequence. So it's in general terms, like just how you would get any term in this guy, you do a sub n is equal to a sub 1 plus n minus 1 times d. Okay, all of these things mean something. D is what we call the common difference. Okay, so D is your common difference, and how you find the common difference is you take any term, this right here, this would be any term, and subtract the one before it, okay? So you take any term and subtract the one before, and that will give you your common difference, okay? So just a couple of things. This is the nth term, so it's in general. A sub 1 is the first term. N is your number of terms, and then D is, in fact, your common difference, okay? So I'm going to say that one more time. A sub n is the nth term. A sub 1 is the first term. N is the number of terms, and D is your common difference. Okay, so these just say determine if the sequence is arithmetic. If yes, then go ahead and name the common difference, okay? So this sequence says 20, 12, 4, negative 4, negative 12. So you're going to ask yourself, are they like adding or subtracting the same thing on each of them? And so let me just kind of like look at it term by term. From a 20 to a 12 would be 8 lower. And a 12 to a 4 would be 8 lower. A 4 to a negative 4 would be 8 lower. Hey, guys, yes, it is exactly correct. It is an arithmetic sequence. Totally fun. Okay, now what's the common difference? Okay, now you already kind of know that you're going down by 8. So if you kind of already figured out that the answer was negative 8, great. How could I do that using this rule that I just wrote up here? Okay, you take any term, doesn't matter. So let's just take 4, for instance, okay? So if I take 4 and I subtract the 1 before it, which is a 12, I do in fact get a negative 8. So there's two different ways to do it. Okay, let's do this next one. So this next one says 9.3, 9.9, 10.5, 11.1, 11.7. Okay, does this look like we're doing adding or subtracting the same thing to each of them? Well, let's kind of investigate. From 9.3 to a 9.9, it looks like we're going like up by 0.6, 6/10. Okay, is it 6/10 again right here? It is, and then 6/10 again. So guys, I definitely feel like that's a yes. And my common difference is 0.6. Okay. If you were to actually like write that out to figure it out, you could do something like 9.9, and then you could subtract a 9.3, and wouldn't you know it, yes, you get totally a 0.6. 0.6. Yeah, I said that right. I thought I said it wrong. Okay, example number 2 says to create your own arithmetic sequence with a common difference of negative 1.5. I was just going to allow you to have like a teeny bit of creativity. So I'm going to give you a drum roll for you to create your own. So just think about, you could put anything for a sub 1, and then you could put, just put the common difference is negative 1.5. So go ahead, create it. You have a drum roll to figure it out. You did it. Good job, everybody. I hope you were able to do one on your own. Okay. Example number 3 says we're going to find the 102nd term of this sequence. So what would be really handy, you guys, is if that I could make an explicit sequence that then I could just plug 102 into. Wouldn't that be lovely? So let's figure it out. What is the pattern here? A 5 to a 13, a 13 to a 21, a 21 to a 29. You know what it looks like, guys? We're going up by 8s, okay? So our first term is going to be a 5, and then our common difference is an 8. So we're going to write the general term, okay? So remember way up here, I'm going to switch colors just so we know what we're doing. Remember way up here, way up here, way up here. I'm just going to make it big, whoop, way up here, right? This is like the rule for a common, for an arithmetic sequence explicitly defined. So we're going to have the 5, which is our first term, plus n minus 1. Now, in this case, your nth term is 102. That's what we're trying to find, the 102nd term, minus 1, and then times by 8. So order of operations totally takes over. We're going to go ahead and take 102 minus 1 first. We get 101, multiply that by 8, and then add 5 to it. And just like that, we get a beautiful answer of 813. So hopefully you were able to get the same thing. Okay, I'm going to go ahead and go to some more examples with arithmetic sequences. Okay. A little side note, if you want to put this in here, this has to do with what an arithmetic sequence would look like if you were to like graph the coordinates, okay? So the graph of a sequence is going to be a set of points, right? So a sequence, where's my little drawing guy? Here we go. Okay, so a sequence is just going to be a set of points. It's not going to be a continuous curve, even though like it's going to have like the same like shape as like a line or something like exponential when we get to the geometrics, right? But it has the same look, but it's not continuous, okay? So this would be an example of a sequence, right? It's just a bunch of finite dots, only defined at like n equals 1 or x equals 1, x equals 2, x equals 3, as opposed to, right, this is the difference between it and a continuous function. So you can see that both of these have the same like shape to them, but they definitely are different, right? This sequence right here totally is just dots. This is a continuous function. It's a line, but they still sort of behave the same way. Okay, if we know 2 terms of a sequence, we can actually find the formula by manipulating, super fun, okay, manipulating the formulas. So the explicit formulas. Oh yeah, don't forget the explicit formulas. Okay, so this is example number 4. It says in an arithmetic sequence, they are just randomly giving us 2 terms. Okay, whatevs. A sub 5 is 24, and then A sub 9 is 40. And then it says find the explicit formula. Okay, so we are going to go ahead and write down what we know, okay? So we're going to take that explicit formula that we wrote down on the previous slide and from the previous slide, sorry, it's wrong words, and then we're going to plug in the things that we know, okay? So we know that you get to do the nth term, so this is what, but we know what the answer is. We know the fifth term is 24. We do the first term, which I so do not know. Then I go 5 minus 1, because I know it's the fifth term, and then times d, which I do not know, okay? I can also do that for the ninth term, having an answer of 40. So I use 40 as the answer for the ninth term. I have the first term, still don't know it, plus 9 minus 1, because I do know it's the ninth term, plus, times d. So we're going to clean both of these up, right? Super, super exciting style. So let's clean both of these up. When I clean both of them up, I'm going to make a system of equations and then solve for the A and solve for the D. Because what happens, guys, is right now I have 2 equations and 2 unknowns, right? So here's going to be one equation, and I need to know what the A sub 1 is and what the D is. And then here's another equation, but it has the exact same 2 unknown things. So that just brings together just like a system that we would do like in an Algebra 1 class, okay? So one of the guys, this first guy cleans up to an A sub 1 plus 4D equals 24. The other one cleans up to be an A sub 1 plus 8D equals 40. And guys, we're just going to solve the system like we would normally do. I think it would be a really good idea just to subtract these, okay? So when I subtract, I'm going to go ahead and change all of the signs of the second guy, kind of like multiplying by a -1, and then straight combo these babies. So the A sub 1s cancel. A 4D minus an 8D is a -4D, and then 24 minus 40 is -16. I solve for D, and so D is 4. Look at that, guys. We are on our way to coming up with the exact explicit formula, because now I know what one of the terms, one of the variables is. It's D, and D is 4. Now, how am I going to get the other one? Just pick one of the equations and plug it back in. So I guess I went with the first one right here. I went ahead and said, okay, A sub 1 is just A sub 1 plus 4 times my newly found D, which is 4, is 16, equals 24. I subtract that, and boom, I get 8. All you have to do now is put all those babies together, and this is your explicit formula. So nice, okay? A sub n is equal to 8. That was the first term, plus n minus 1, and then times 4. And now we can find any term that we want to, and there's our explicit sequence. If you want to, only if you want to, I will actually have both answers. You could actually clean this up and go ahead and distribute this 4 here and here, and then combine like terms. But honestly, it's not necessary, right? It's just another way to write it. So you can write it either of these ways. Mrs. Fox is totally fine with just this first way, and then she's totally fine with just this this second way. I actually probably on my answer key have both of those versions, okay? So then let's go to putting in arithmetic means in a sequence, okay? So this is another application of doing arithmetic, an arithmetic sequence. So it says if you want to write this down, if A sub 1, comma, A sub 2, comma, A sub 3, comma, dot, 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 comma, A sub k minus 1, comma, A sub k. Okay, what is all of this saying? We're just going to have a sequence, guys. It's got so many terms on it. This is the last term. This is the term before it. And we got some terms at the beginning, okay? What that means is that if they gave you the first guy right here, okay, and then they gave you the last guy right here, you should be able to fill in all of the middle terms as long as you know how many of them there are between that first and the last term, okay? So we're going to just kind of like do an example with this one. Okay, so all of those terms right there are called the arithmetic means. Okay, so example number 5 says find 3 arithmetic means between 9 and 29. Okay, so what that means is that the first term is a 9, the last term is a 29, and then there's 3 spots in between. Okay, so I'm actually just going to set it up. I'm going to write 9, and then I'm going to put a comma, because that's what you do when you have a sequence. You separate the numbers by commas. And so 9 comma 1 space, comma 2 space, comma 3 space, comma 29. Now, you could actually do this question the exact same way that we did the previous example, number 4. But I would like to streamline that for us, right? To make it a little bit just easier to do. So the way that the streamlined formula works, okay, is that you actually take the 29, the last term, so this is the last term, and then you subtract the first term, okay? So our common difference is going to be the last term minus the first term. So for us, it's 29 minus 9. And then we divide by the number of like steps it is from the first to the last, or I like to count commas, actually is what I do. So because I've set up my list beautifully, I have 1, 2, 3, 4 commas, or you can think of it as 4 changes. So 1 change, 2 change, 3 change. That was a little bit of a funny little jump right there. Sorry. And then a 4th change. Okay. So you just multiply, excuse me, no, don't multiply. Scratch that. You divide by the number of changes there are, or you can simply count the commas. Okay. So that's basically what it is. You can write it in English as like a little help for yourself. So it's the last minus the first, and then divided by the number of commas. Okay, so now for us in this particular problem, okay, we get that the common difference is 20, because 29 minus 9 is 20, and then divided by 4, so the common difference is 5. Now, here's the thing. You have to go back and put those answers in to the thing, right? So you have to go, you know that the common difference is 5, but we haven't actually found the numbers that are inside of it, okay? So you're going to go back to your 9, and then you're just going to keep adding 5 until you get to the 29, and it's totally going to work, okay? So 9 plus 5 is 14, add 5 to that is 19, add 5 to that is 24, and then as a double check, add 5 to that and it totally is 29, right? Easy, easy. So that is actually the answers to this question. It's 14, 19, and 24. Okay, we are now, where's my drum roll? Here we go. We are now going to learn about a geometric sequence. So put that arithmetic sequence to bed. You know all the things about the arithmetic sequence. Now we're going to do the geometric sequence, okay? So again, we always want to write it down in the math notation because it's important, right, to just have that as something to refer back to, even if we don't necessarily use it, okay? So for the geometric sequence, okay, this is defined recursively. It says a sequence, a sub 1, comma, a sub 2, comma, a sub 3, is going to be geometric if there is a constant R. Okay, so now we have a different letter for what's happening here, a constant R for which a sub n, so any term, is the previous term, a sub n minus 1 times that R. Okay, and for n greater than 1. Okay, defined explicitly, we write it like this. And again, guys, this is important for us to know, and this is what you're going to want to memorize, okay? Because you are going to have to memorize some of these. So this formula right here, the general term, is going to be a sub n, and that's going to be equal to a sub 1 times R to the power of n minus 1. Now, it is really, 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 really important that we do order of operations. On this, you're always going to want to do the r to the n minus 1 first, and then multiply by that first term. Okay. Now, how do you find that common, that R value? It's called the common ratio. That's why they use the letter R. Okay. And so the common ratio is going to be a term divided by the previous term. Okay. So you can take any term that you want to. It doesn't matter which one, but you take a term and then divide by the previous term, and that will give you what your common ratio is that then you can plug into it. These can be negative numbers. They could be fractions. So just be aware of that. Like if you end up like having a sequence where you're dividing by 2 all the time, you're actually not going to write divide by 2. You're going to write times 1/2, right? And so you just got to be careful, like, is it getting smaller or is it getting bigger? If it's getting smaller, probably there's going to be some sort of a fraction that's less than 1. If it's getting bigger, the number is going to be larger than 1. Okay. So this one just says to create your own sequence with a common ratio of R equals -2. I might just, I don't know, I'll just start with any number and then be multiplying by 2. Maybe you do one for yourself. So let's do our little drum roll again. You guys just create one, like just write one out where you start with any number that you want to, and then go ahead and keep multiplying by -2. You have an entire drum roll to write one down for yourself. Go. did you do one? I hope so. Okay, so while that drama was going on, I was thinking to myself, what am I going to write down? So I decided maybe I'm going to start with the number, I don't know, it doesn't really matter. Maybe I'll start with 2. Okay, so if I have 2 and then I multiply by -2, my next number would be a -4. Okay, and then my next number times by -2 would be a +8. And then I have another one and I would multiply by -2 and I would get -16. And then I would put a comma and then just go dot, dot, dot. Okay, so that is an example. Guys, that's one example. You could have done anything in the world as long as you're starting with a number and then multiplying by -2. Okay, so then this one says, find an explicit formula for the geometric sequence. Okay, this guy has a sequence and it says 4, 20, 100, 500, and then it says use it to find the 9th term. Okay, I think we could totally do this. So let's go ahead and figure out what the pattern is. So guys, what does it look like? A 4 to a 20, a 20 to a 100, a 100 to a 5. Does it look like the same thing is happening each time? I actually think so. I think that we, for each term, are multiplying by a 5. Now, to confirm that, what I could do is I could take any term, like 100, okay? So if I take 100 and then I divide by the previous term, which is a 20, do I in fact get 5? And the answer is, actually, I do, okay? So that is one way to do it. So our first term, when I look at it right here, is a 4, okay? And then my common ratio, just however you want to get it. I decided up here to do 100 divided by 20. Down here on the PowerPoint, I did 20 divided by 4. Guys, it's going to work every time, right? It doesn't matter which terms you use. So 5 is totally our common ratio. Okay, and then here is our formula. Okay, so the formula from the previous slide and that you boxed up, put a giant highlight on that because that's really important. Okay. It says that a sub n is equal to the first term, which is a 4, times 5 to the n minus 1 power. Now it asks us to find the 9th term. So folks, we're going to go ahead and plug in 9 for the value of n. So a sub 9 is going to be 4 times 5 to the 9 minus 1. Now in your calculator, you need to do 5 to the 8th first and then multiply by 4. And if you do that, you get a beautiful answer of 1,562,500. If you did not get that, whoops, go back and try that in your calculator again using the appropriate orders of operation. Okay. Something that we can also do, just like we did with our arithmetic sequences, is talk about geometric means. Okay. So we did arithmetic means where we wrote the list, we put some spaces in between, and then we figured out a cute pattern. We're going to do the same idea, but for geometric means. Now, the process is a little bit different, but we are going to do, again, a streamlined version, right? Okay, so this says we're going to locate 3 geometric means between 4 and 324. Okay, so what that means is, so let's write that down, locate 3 geometric means between 4 and 324. We're going to write this sequence out. So 4 is right here. That's our first term. And then we're going to go comma, 1 space, comma, 2 space, comma, a third space, comma, 324. Hey, folks, quick question, like sidebar. Is the number always 3 when we do the geometric means and arithmetic means? No, this is just a coincidence, okay? So you can have as many as you want, and the book is going to have you do, the homework's going to have you do all different kinds of them, okay? But 3 is kind of like a popular number that we like to do. Okay, so we're back. Sidebar over. And so let's go ahead and do 4, and then we have all these guys. So again, we're going to do a streamlined version, you guys. A streamlined version, so we don't have to make a system and like have to take the log of both sides. That like seems a little bit like, whew, that seems exhausting. I don't want to do that. Okay, so I mean, seriously, who has got time for all of that? No one's got time for that. Wait, we all do because we're stuck at home. Totally kidding. Okay, I'm jesting. Here we go, guys. So let's go ahead and do the streamlined formula. So the streamlined version of this is you're going to take the last guy, which for us is going to be 324. So that's our last term. And then we're going to divide by the first term, which is 4. And then we're going to take the root of that. Now, what root? Not the square root on this one, but the number of commas again, or the number of changes. Remember we talked about number of changes? So 1 change, 2 change, 3 change, and then 4 changes. So this is going to be the 4th root of 324 divided by 4. Now, you have your calculator with you, of course, so you're just going to put this in your calculator. Maybe I'll do 324 divided by 4. I'll get 81. And then I'll take the fourth root of 81, which, guys, you got to be careful, is actually plus or minus 3. Oh, tricky. Don't miss that. Okay, because really, negative 3 to the fourth is 81 and positive 3 to the fourth is 81. So now what we're going to do, guys, this is what the common ratio is. Okay, I probably should have put over here that this is what you do to find the common ratio. Okay, so maybe just add that to your notes. So this is what R equals. And so now you actually have to perform those multiplying by the common ratio. Okay, so one version is to multiply by the positive 3. So 4 times 3 is 12. That times 3 is 36. That times 3 is 108. And then just as a check, 108 times 3 is totally 324. But guys, there's another answer. There's another set because we had two choices. Okay, so now we're going to do multiplying by negative 3. 4 times negative 3 is negative 12. Negative 12 times negative 3 is positive 36. That times negative 3 is negative 108. And then we're back to our 324 being a positive. So that is all of the two sets of answers. And actually, there is two sets, okay? So you would have to have both of those sets. Okay, I think we have one more example question. It says a single geometric mean. So what if they wanted you to do the geometric mean, but they only wanted one of them, okay? This one is called dun, 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 the geometric mean, okay? So if you're only doing one of them, then it's just going to be the geometric mean. And there's just going to be like the one answer, okay? And so it's going to actually just be the square root of the two values multiplied together, and then it's going to be plus or minus because that would be appropriate mathematically, okay? So this M is not standing for slope for this time. This M is standing for the geometric mean. Okay, let's do one example of this. Oh, side notes. Side note. Oh, I love my side notes. Okay, so the side note is that the signs must be the same. So if they ask you to find the geometric mean between a positive number and a negative number, it is so not going to work, okay, at all. So definitely it's going to be lovely. It's just going to be perfect. So let's do this. Okay. So example number 9 says find the mean proportional M if it exists between, and then it gives us a couple of numbers. So what's interesting, guys, this mean proportional, they are saying this basically right here, this mean proportional is another way to say the geometric mean. Okay. So these are actually synonymous with each other. And so we're going to go ahead and do it. Now, does this guy work? Part A? Yeah, Mrs. Fox, because both of these are negative numbers. So I'm going to take the square root of a negative 42 times a negative 38. I don't know if that works or not, but let's shove it in our calculators. So we shoved it in our calculators. And just like that, boom, we totally get it. It's actually 126. We need to put a plus and a minus because it is a number that will work for both of them. Little background noise, guys. Sorry about that. Hi, Mr. Helicopter. Sorry about that. My bad, my bad, my bad. I guess this is what happens when you try to film outside, but it's probably quieter than being inside with all those crazy kids of mine. Oh my goodness. Might have just locked myself outside. I'm totally kidding. I'm totally kidding. Okay, let's do one more example. So this says what is the mean proportional between 1 and negative 16? And you're like, wait, hold on a second. We can't actually do this question. You totally guessed it right. Good job, guys. That is because 1 is positive and 16 is negative. So there is no solution. We'll just say does not exist. And boom, just like that, we are done with our notes. Ladies and gentlemen, here's your homework assignment. Okay, I wrote you a little note that says there are several word problems. Okay, there are several word problems in the homework. And I know how much you absolutely love, adore, and appreciate word problems. Just make the sequence, okay? Make the sequence with the numbers. Pull out the numbers and then apply the rules on whether it's arithmetic or geometric. Okay, ladies and gentlemen, that is basically it for our notes for today, which I'm super excited about. I hope that was a great lesson for you. We're just going to keep on jamming, keep on learning. Please, 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 please keep on submitting your homework through Google Classroom. Upload the pictures. If you're having trouble, let me know. You can always do something different. You can do it through a remind. Just let me know. And I think that's it. So fanfare music to end the lesson. And let's get out of here, guys. Back to your regular scheduled programming of, you know, lounging around in your pajamas. I know how it works. Bye, guys. I'll see you later. See ya.